Okay, cool. Welcome to the weekly EZKL community call. Today's May 8th. I thought I'd do these introductions because I'm looking at the YouTube videos and it would just start off with a straight conversation. You know, you just gotta intro the video. But I hope everybody's doing well. We can start off with just some general performance updates for this week. And then maybe new features like the WASM verifier and also the new PyZKL features.
Yeah, for sure. I guess there haven't been like a ton of performance centric updates. Slowly that we've there's a few things like performance wise. The first thing is that we upgraded the version of tracked Onyx that we use, and they had a bunch of like performance improvements on their end in terms of like loading a model into memory. So we've benefited from those. But in terms of like performance updates, the big one still is the parallel layouter. And I'm working with the Halo 2, well, not the Halo, well, partially the Halo 2 team and partially the privacy scaling explorations team to merge that into the main Halo 2 repo. So once that gets through, we'll have like much faster layouts for the basically gigantic models that we have. I actually don't know if anyone's building circuits with as many constraints as we have, because people were kind of surprised that we managed to get something this size into Halo 2. Pretty sick. We're definitely pushing the limit of what's possible. I think in terms of features, like the big one is all the stuff that like JSeam did for Python, and like it'll be better placed to speak on that. But I created like a small tutorial in a Jupyter notebook that built on top of that. And then on my end, like I rolled out a verifier and a prover for the WASM32 unknown targets, which is pretty cool, which means you can now like verify and prove in the browser, which basically a bunch of applications, I guess, that were being started last week required, which is quite cool. So in terms of usability, that's quite nice. Basically, it means like if you're developing like some JS application, it's really, really easy to plug and play now. Well, as easy as WASM lets you lets
Yeah.
itself, basically.
Is the unknown target just for like general architectures, or is that something else?
Yeah, it's like a browser environment basically. Whereas
Oh, I see.
WASM32 WASI is like, yeah, if you're running on native. It's like a good alternative for Docker or something. If you
Okay.
just ship that sort of executable. But when you're working with like WASM bindgen and stuff, you're passing JS values between the browser and like the WASM execution environment. You have to like serialize in between the two. That's why it looks a bit different to what we had before.
I haven't tested yet. The plan to test on the next that uses ZKL that we built. But I just got curious about how does the WASM handle the story, and because before you needed to store the Onyx file and the V key and the verifier key like locally.
Okay, so that has to be passed in from the browser. Like, so the browser has to load it in from somewhere. So it could just be, again, I suck at browser stuff. So maybe it's just like a GET request to like some endpoint, and then I don't know. Depends on where the Onyx file is stored, basically.
Yeah,
But yeah, if
That's,
you're,
yeah.
I think the ideal thing I want to move towards is one where you don't need the Onyx file to prove, because basically when you load the Onyx file, it gets, you know, there's this intermediate representation of the model where like everything is quantized. We have our own graph of operations and stuff. And that I would like for that to be serializable, but there's a bunch of like Halo 2 types that don't play nicely with that. So I'm making my way towards that. It may take a bit of time. Well, and it's kind of annoying because the prover in the browser needs to do that whole operation of like taking in the Onyx, creating the intermediate representation, and then generating a proof, which kind of sucks because you don't really want the browser client to have to do all that work. But yeah.
I see. And right now, was it merged to main, the separation between the setup and the proof?
Yeah, that's all. Yep.
Okay.
Separated.
So then,
so there's an intermediate step. Yeah. Because I know you wanted that, right? You wanted to have like a separate step for the verifying key and the proving key generation.
yes, because then it makes the proving, at least the proof flow, a lot faster, like a bunch of seconds faster, depending on the model. So now when we tried the proof, the normal proof, it will not. Or maybe that's why some things were breaking, because we didn't update it. So it's like when you generate the proof, it's not generating the VK and PK anymore. So you need to already have there and then just send the path.
Yeah, exactly. So
Okay.
if you watch the new video in the README, there's that little setup command that gets called right before the proof. So it's in there. All right. But yeah, that's kind of it on my end. I'm gonna be working this week to like wrap up the parallel layouts and stuff with the Halo 2 folks.
Great. And then also maybe the custom errors.
Yeah, that would that would also be cool. I know there's quite a few people that have asked for that. And I guess the privacy scaling explorations team, I think there's even a to-do in the errors or something that nobody's touched for a while. So it's something they're kind of aware of. For context for everyone, like there's a bunch of functions that we use that can't return custom errors. And we have to use like the Halo 2 error types, but they're not informative at all. It's just like, yeah, so we get close to no information when things break sometimes, which is kind of annoying.
Yeah, slowly but surely. I also wanted to bring up the fact that, well, just with the new setup, prove, verify commands that you were talking about, Danilo, in our new docs, we have, okay, so I just pushed the changes for the updated commands, but it hasn't updated on the website yet. But it should be just a little bit of time for the workflow to get that. But for the new process of generating a circuit, you can refer to those. And Jayseem, did you want to talk about the Jupyter Notebook example?
Oh, yeah. So there are a few issues with Python right now. So the bindings work. The only catch is that I think there's some interaction between Python and Rust. So certain examples can take much longer in the Python bindings. So I naively assume that like things would be running separately on Rust. But I think like there's an example where it took like 85 minutes. So yeah, so I think there's some issue with like maybe the Python global interrupt lock in Python and like Python types. So yeah, I'll give it a look. So I think the problem comes with like the interaction with like Halo 2. So it seems to be running fine on things like the forward and the other operations, but for the for the Halo 2 proving operations, I think there might be some weird interaction that's happening in the background. So occasionally it can take quite a long time to run the prover and the verification step. Yeah, so I'll give it a look and see whether this can be fixed, or is there like some like work around this.
Yeah, Jayseem, just as a comment, it could be or it could not be. But I like when we were doing the server during Josaldo, I was also taking like a lot of time. And what I realized, and actually what Jason told me, is that if you run the cargo run without the release, it takes a lot more time. I don't know if that could be the case for Python binding, because I don't know how its setup, but like if you run with cargo run -- release, like it basically makes everything almost 10x faster. So
Ah,
I'm not sure if
Oh yeah,
okay.
does Maturin compile in release mode by default? Or
No, no,
that's
no.
what I
I
would
think
have
that might be
assumed.
I think that might be the reason. So I think in the docs, I used like Maturin develop. So I think that was like the production, not the non-production version. So I think that might be also a culprit. So yeah, I'll upload like the new
Oh snap.
uh yeah, I think that might be the
Yeah,
problem. So
that's funny. Yeah, Halo 2 is insanely slow in debug. It's like hours and hours to do anything. So hopefully that's it.
yeah.
Fingers crossed.
Oh my. Okay, okay. So all right. So I guess on that note, like I think the plan is to then import the bindings into PyEZKL instead. So you should be able to run something like pip install PyEZKL. So I'm not sure whether we will stick with PyEZKL or like pip install EZKL. So I think it's up to uh, Jason to kind of decide on which one to use. Yeah, but what would happen is that I think my plan is to then like allow people to do something like pip install like EZKL, and then you can run it a production version locally.
Yeah, nice. I guess yeah, because I think people got confused as well by like the fact that the Jupyter notebook had two different libraries, like PyEZKL and EZKL lib.
Mhm.
Yeah, that's it from me for like the Python binding side.
Cool, cool. Good. Okay. Other than that, did anybody else want to talk about the projects that they're building on with EZKL?
Yeah, I mentioned that I was going to share some how we built Baby Gaia.
Oh yeah.
Uh, because there's going to be an autonomous world hackathon, and I was trying to run today, and there was issues, so there's no live demo.
No worries.
But is anyone here specifically for Baby Gaia or the autonomous world zkml integration? If it is, I can go a little bit deeper. If not, I can just go more conceptually. Okay, I guess I can go more conceptually. So basically, what we did for, and I think this could be a very interesting strategy for actually any zkml implementation, is when we were creating a game, the Baby Gaia game. Just for context, it was like a simple game that you can mine things, and the word have 12 by 12, so it's like a 12 by 12 box. And each box you have different elements like grass, water, and what the machine learning did was to update the word state. So it would decide if you want to spawn more grass, more water, or different elements. And the idea is that it will say the word is conscious, and you don't actually know how the word will update if the model is complex enough. So that was the idea. And what we did is that we first plugged that in with ChatGPT to start exploring possibilities. Because if you go with a predefined model, like you basically know what's going to happen, but we want to have some creativity and some exploration aspect. So what we did is we plugged in, and then we prompt ChatGPT to always like return the new word state based on the changes on the world, and also explain. So it was quite interesting. Like as you would get some grass, ChatGPT would define if it wants to put more grass or more water, and we gave the intention to ChatGPT to balance the world. Because basically giving the intention to ChatGPT is basically saying like, oh, train go towards this direction. When we train to a specific data set to have a specific output, we're just giving the intention. It was really interesting because I felt that prompting was actually a language for creating machine learning models on top of LLMs. So like, as we prompted and we started to like say to the different things, I felt like I was creating a specific machine learning model. And then what happened is that we started to see some actions, like ChatGPT would create some different elements that wasn't expected, and then would start to create these narratives, and like it had the creativity aspect and also like the knowledge aspect of what is a world, like what are elements, how each element connects to each other, like why you need water, why you need air, why you need grass. So ChatGPT has all that knowledge, so it was quite interesting. So we started to simulate with that. Once we had some data and once we had like a grasp of what would be interesting, then we created a PyTorch model, a normal machine learning model with PyTorch, focusing on the things that we learned. So like basically it's like it's an open world with ChatGPT, but then once we saw, okay, we like this, we like that, and then we got those data, and then we defined a much smaller model focused on doing the things that we thought it was interesting. And then that model was a lot smaller, and then we transformed that into a ZKML model using EZKL. So, and then basically we had 36 different elements. And in this case, we don't have like, you cannot create things that is not predefined anymore, but it was complex enough for a 12 by 12 world. And then what we did is we transformed this model. We got the data from ChatGPT to train this model, and then we trained this model, and we used it to update the word states on chain. We didn't implement the verification contract because we didn't have time, but we just got the output and like change the state on chain. But basically that was how we implemented a simple EZKL machine learning model on chain. Basically you use like more intelligent and bigger models to generate training data. And then with that training data, you can train like really small and specific models for specific tasks. And basically that can allow you to have some interesting mechanics. And I think this could be replicated to many things. So yeah, hopefully it helps. And basically, if you want to learn how to use EZKL, you can just go to the docs and literally follow step by step. We can share the server code, but right now it might be outdated because now the setup and the proof is different. So we need to update that. So yeah.
That's cool. I think the server code would be super useful for lots of folks. Yeah, something I wanted to explore, which I'm probably going to explore in the coming week. And actually, I know, JC, you have experience writing contracts and stuff. And maybe eventually this becomes like a MUD integration, like an integration with MUD. But part of the idea that I had, now that we have like the WASM prover and verifier, basically we're in a position where, let's say you have a really expensive function in a smart contract that involves lots of computation. You can wrap that up. You can basically express it as like a PyTorch graph. If it's like, you know, a bunch of additions or multiplications, and you can create a snark really quickly. And basically, instead of having the contract do the computation, you shift the burden of computation to the person that's calling the contract. So the browser client does all the calculations that the contract would normally do, generates a proof, and then submits that proof as part of the call data to the smart contract so as to reduce gas cost. So you start to shift like the burden of computation, so like the chain, to lots and lots of browser clients, but you just get a proof that they ran it correctly in a way to like reduce gas costs in a kind of interesting way. And it also means that you can start to do like more complex stuff in smart contracts. Like if you want to do giant matrix multiplications or whatever, or it doesn't have to be a neural network, basically. You can start to do that in browser clients and shove that into call data. And then the contract just has to verify that the proof you generated was correct so they can trust the results, basically. But that would be kind of the idea, like creating a small demo with that and then seeing, yeah, seeing if there's any interest in using that. I was speaking to Ethan earlier. I don't think he's on here, but yeah, he's building a lot in DeFi and stuff. And I know there would be interest on his end and some other DeFi apps basically to leverage this, because like some of the rebalancing for pools and stuff that occurs in a contract can be pretty expensive for end users. So it'd be cool to reduce that cost more broadly.
Yeah, I have a question around this integration way, which I think it's amazing. Would the like, let's say I write the logic for some interactions on the game, would I also need to write the PyTorch model for that, or that would be handled by MUD?
Yeah, well, it depends. It depends how well integrated this is. I guess part of the idea is that you shouldn't have to write PyTorch at all. Like once you define it, the idea would be like, to be honest, like the ideal scenario is that you write the contract in Solidity, and then eventually it extracts all the expensive operations and then just puts those, and then just creates verifier contracts for that. That would kind of be the idea. If there's like a for loop that's just like adding numbers and stuff, it should be able to detect that and then just compile it to like or create a call to a verifier contract and then create the verifier contract for you. That would be the ideal situation I would want to end up in, basically.
I
So
think
what
that's
do you can go ahead, Danilo.
okay. I have this second question is, in that case, wouldn't it be easier to convert directly to a Halo 2, or like, because you already have a very predefined code?
Oh yeah. So that I think we would skip PyTorch, but for now, like that's what I'm gonna do for the demo, basically, because I don't have a Solidity to to Halo 2 compiler written yet. But yeah, I think the idea would be like I have some operation, I can express it as a computational graph, and then hopefully like maturing is like the interaction between Python and Rust is a bit faster, but then you can just generate a proof or something, and then we go from there. But yeah, we'll see. I guess because I suck at browser development, it would probably be from like the command line to begin with. So it would be like contract calls from the command line or something to reduce gas costs. And then eventually one day I'll figure out how the browser works.
Yeah, that's actually what I was gonna ask is like, what does that interface look like? Is it a smart contract library or something like a Ethers
Well,
JS where you're passing call data to the front end?
Well, I guess for now, like all it would be, I guess in the browser, all it would be is like, so obviously you have the ethers, you would interleave it with calls to the WASM bundle that's getting shipped, basically, along with the rest of the assets. So yeah, if you're preparing call data, you would just have to call the WASM bundle and pass the requisite values, basically. But what becomes kind of interesting is that if all the values that you're fetching are on chain, it becomes very easy for a verifying contract to just pull in those values from the latest block and then verify that you ran those computations correctly. Like if all the data is on chain, you don't need to do anything too complicated in terms of like, I don't know, like committing to data or determining that things have good provenance or something. So it's kind of neat if this stuff just pulls on-chain data already, like most smart contracts do. And really all the contract is verifying is like, given that pulled in data, did you compute the right thing?
Interesting. Yeah, you could probably use Axiom for that to get the data from the smart contracts.
Well, yeah, you can just use ethers or whatever. It's just like an RPC call, really, for like smart contract state.
That's super cool.
But yeah, that's the idea. I'm gonna try like a small demo, hopefully that is easy to use, and then someone can like someone can tell me whether it's shit or not, or great. Yeah,
That would be
hey,
cool.
you have a
Yeah, Hadi.
there's someone with a question. Howdy.
Yeah, can you hear me, guys?
Yep.
Awesome.
Yeah, I can hear you.
Yeah, that's it. I was listening to and I got excited about the thing that I was hearing because that's a really good point to reach in like a future month because we like let me explain to you what we are building using EZKL. Just a second to close the window. Okay, so we are trying to build a DeFi platform for optimizing yields and basically lots of other stuff. But our main target is optimizing yield using AI and basically creating a platform with minimal trust assumption possible. So we are like in our roadmap and our vision, we imagine Noya to be AI models that predict yields and like with a thorough backtesting. And the point here is that the strategy managers in the system are obligated to run the AI model to the same AI model that has been used for backtesting in the production. So the point of using EZKL or something, the zkml technology is to prevent the strategy manager to do something fraudulent and steal the money. So this will allow us to create an environment with least trust assumption on the strategy manager. We started working on EZKL like last week, and we had a really good developer experience with this. We were able to create and verify simple models for now, and we are trying to step by step improve our models and like include more pools and more advanced stuff into our models.
That's awesome, Heidi. Wait, so I had a question. So in terms of like getting data like price data, how are you all aggregating that and collecting it for the model?
So that's also like one of our challenging positions right now, because we are challenging questions right now, because we can aggregate data from lots of sources, but for a verifiable computation, we need a verifiable source of data as well. So we are exploring the solutions to like how can we find a verifiable source of information for our model to be run with it. But even if we fail to do this, like even if we fail to do the input verification, it's still a win for us. Why? Because like verifying the input by it's much easier for other people than verifying the output of the computation. So we are still trying to find input sources that are verifiable. We are negotiating with Chainlink to see if they can provide us something we just need a signed data. So they say that, okay, this is the data and we signed it, so people can trust, for example, a third party like Chainlink. Yeah.
That's cool. Yeah, Chainlink would be a good one to roll with. I don't know. I'm kind of remembering talk about Uniswap being like a verified on-chain price oracle.
Mm-hmm.
Have you heard of it?
Like Yeah, but the problem is we are not just using prices information.
I see.
We have like a really long list of data, and it's really hard to like have all of them on chain. I was talking with I think JSIM in Telegram, and like we were talking about this, and he said that if the data is on chain, it's easy, but if like some of these data, for example, like old data or data on other chains that will affect this chain, is not easy to fetch on a smart contract.
For
Yeah.
sure. For sure.
Yeah, I'm wondering if like I'm guessing like the data you're using is a bunch of features basically calculated from price data. Is that correct?
Not necessarily from the price data, because like we are mostly using yield platforms, and we are including lots of data, for example, APY history of, for example, Aave and trades on Uniswap that will give rewards to the users, and these kind of like information, mostly also the price data. So that's our challenge here.
Gotcha.
Yeah, we are also like because you are the experts here, we will be really happy if you have any comments on how we are if you have any comments on our approach, or if you want to talk further about the details, technical details, we would be really happy.
Yeah, you can definitely keep messaging in Telegram, and I'll definitely respond there.
Yeah, you are a really good helper for sure.
Yeah, tech support for sure. Yeah, is there not historical price data on Uniswap? I remember they had some sort of accumulator. I can't remember. Did they roll that out with V3 or something? Let me check.
Yeah, they have.
Oh yeah, they have accumulator checkpoints.
Yeah.
On-chain TWAPs. I would start by using those if you can. Like data provenance is a really tough problem. Like it's a pretty tricky problem to solve. If you want to do it cryptographically, it's almost impossible. And I guess the issue with like oracles like Chainlink is that oracles can go down at
Yeah.
a lot of points. I guess it depends on like how distributed the contingent of oracle, well, how many people are running the oracles on Chainlink, but I know there can be issues with that for sure. Like there's so many exploits that come from oracles, right? Like it's such a point of weakness that like I don't know. I guess like having a verifiable model is fine, but like
Yeah, exactly. When the incentivize for being honest get less than the reward of being fraudulent, it will be like it makes sense for the actors to go the bad way.
yeah, I mean, I would be curious to see if you can do stuff with like the accumulated, like the tick data that that Uniswap accumulates, because a lot of that stuff is stored on chain. So it'd be kind of cool to like see what you can do with that. Like I've seen a lot of DeFi applications that just leverage oracles, right? Or that leverage Oracle price data. And even if you slap ZK on top, yeah, I don't know. I guess it still seems like a point of weakness at that point.
Yeah.
Yeah, I mean, maybe for
Yeah,
an MVP, it would be good to
yeah.
just use, on-chain data and then expand to oracles and more verifiable data resources from there?
There are some problems with the AI model that we are running, because it will be useless if we just limit ourselves to on-chain data.
I work with Hadi on Noya, so I would just like to add, for example, like if we're predicting the yields on curve omni-chain, so the curve on optimism for example, USDT, the Tri Crypto Pool, would affect the yield on Ethereum for like the SUSD pool, right? Because all of these inputs affect each other. So if the APY goes higher on one chain, the APY on another chain goes lower. So they do not exist on chain. It's impossible. The only way I'm thinking of it is to have like maybe some game theory, some crypto games to ensure the correct inputs. Other than that, like on chain, it's impossible to create because we're predicting yields omni chain and not just on one chain.
I see. That makes a lot of sense.
So it's like a cross-chain strategy. Okay.
Yeah, exactly. So it's a cross-chain yield aggregator using multiple protocols, and to do that, you need to get all of the information across different protocols, across different chains, which makes it super complicated, to do it just on chain.
Yeah. So
cross-chain messaging doesn't apply to this, right?
Well, of course, we need to do some on-chain messaging for bridging, for example, and for vault management and stuff like that. But regardless, the inputs for the model cannot all be on-chain.
Exactly. Okay, got it.
But I mean, it's a huge improvement, honestly. Like instead of trusting a strategy manager, you trust a model that's working. And now we move the problem from model execution to proving inputs, to improving reliable inputs.
For sure.
Gotcha. Gotcha.
I'm just curious how big the model you all are using is.
I think Pablo here. I don't know if he's here.
Yeah, we're currently using a boosting of decision trees because it's better for classification model. I'm trying to train something similar in Python with our current network, a couple of hidden layers, or some simple transformer. But it's really hard to learn quick wages in such small data. So for now, trees are more stable and more have better result for us.
Okay, so like currently decision trees and then trying out recurrent neural networks and transformers?
Yeah, mostly because we talk with Danilo and you implement basically PyTorch more natively. So trying to have a similar RAG curve or similar accuracy with a neural net model.
Cool. Yeah, this sounds like a really interesting project. Do you all have a name just to ring a bell?
Yeah, Noya, Noya stands for Native Omnichain Yield Aggregation.
Native Omnichain Yield Aggregation. Awesome. Noya.
All right, and I'm gonna take a stab at the basic decision tree model at some point next week, and then I'll let you know how that goes. But we have all the base operations for that. Like a lot of decision trees are just like greater than or less than comparisons, basically split up across a bunch of nodes, and we already have like all those sorts of operations implemented as like circuit constraints. So it might be okay, and hopefully it is. I'll let you guys know how that goes.
Thank you very much. I mean, we truly appreciate it.
Yeah, for sure.
And also, I'm right now working on the integration of our ML model into our smart contracts and the verifier smart contract, and like the border between the execution and the verification. So like it will be, I'm working on it currently, and I'll be happy to have your review and your comments on my code after it's done, in maybe tomorrow or the day after. So yeah.
Yeah, I'll
Also-
see how much time I have for the rest of the week.
Right.
But yeah, ship it over, and then if I have time, I'll take a look for sure.
Sure. That would be great.
All right.
Also, like
Awesome, guys.
something came to my mind, like about the data problem. So like our we can solve it to look at it the way around. So instead of proving the input data, we can have like watchers, like in decentralized watchers that will observe the network. For example, we can the community can hire a third party to like do this.
Hmm.
Yeah.
Wait, I'm sorry, I don't think I understand. Like, I hire a third party to run the model or
No.
manage data?
To just check the input model is correct. So if
Oh,
we
okay.
are
I think
saying
like optimistically, yeah. So optimistically.
yeah,
something.
optimistically.
Mhm. Okay,
Yeah.
got you. So you can submit like a
Gotcha.
fraud proof saying that
Yeah.
these inputs are not
Exactly.
valid. That's interesting. Okay. Yeah.
Gotcha.
Super cool. Thank you for sharing,
All
Noya.
right.
Sure.
Yeah,
Thank
thanks
you
for
it's
hopping on
cool
the call,
to-
guys.
Awesome.
Thank you.
What was that, Hadi?
I said thank you all, guys.
Oh yeah. Thank you.
Oh yeah.
We'll maybe we'll see you next week.
Sure.
Keep in touch, on progress. And then for all of you all, just feel free to use the Telegram for any, debugging or issues.
Sure. Yeah.
Yeah, fire away there. All right, guys.
Awesome. Cool. If
Thank
nobody
you,
has anything,
everyone.
I'm gonna go ahead and stop the recording. Okay.